Okay, we are recording. Just go.
Okay, so my presentation today is going to be loving Go and hating the language. My name is Victor Freire. I've been working with Go since 2018. I really enjoy the philosophy, but I do hate the language. So, some Go history, just to start. It was created in 2007 at Google, and it went public in 2009. It was designed by the known guys from JavaScript V8, Unix, and C. And they had some goals which would fit Google's use case. This is really important. Uh, it should be small, so it should basically give you the tools to build things, but not abstractions to actually build the things. It should have a really fast build time. It should have easy concurrency, and it should not be Java or C++ ever. Uh, One little note on the fast build times, it is really fast because, well, Google has a lot of lines of code. It has a monorepo, so the compiler has to do a lot of work to strip things. And Uber actually has a 50 million line monorepo of Go code that actually can be built and deployed in 15 minutes. So they actually do at least 50 builds every hour, and every build takes like 15 minutes to deploy and go live. So anyway, the influences of the language: C and Pascal for syntax, Oberon family for struct methods. You can basically assign methods to structs, something that was missing on C. Its module system, which is really, really simple, and Newsquick for concurrency. Newsquick is really interesting because it was used as a way to communicate between UI. It was a Rawpike research. And below you can see the similarity of the module system between Oberon and Go. And after after seeing the influences, like the language influences, I guess the most asked question is, why not generics? Why did they keep this out of the language? So both Oberon and Pascal had generics, and they basically avoided generics because it would make the compiler code bigger. The implementation would be way more complicated, and what when I say that the source code would be bigger is that Go was actually bootstrapped on the C compiler of Plan 9. So it was really small, really contained code, and they didn't want to give up on that. So this is one of the reasons. And they actually always said that maybe in the future they would introduce the feature. So, as I said, Plan 9 had a really big role on Go, so it might have been like the biggest influence. So, some of the influences on the language and tooling itself is static linking. Plan 9 actually avoids dynamic linking when compiling. You should use the 9p protocol to talk to process instead of linking libraries. For instance, the whole idea is that you shouldn't have like a X server running on your computer if the network already has a X server. You should just use 9p protocol to communicate with the process. So static linking would be easier to maintain. The compiler and assembler. The compiler was basically the C compiler, so really the same code base from Plan 9, and the assembler is actually based on the Plan 9 assembler. So uh, till this day, the assembler is the same, so it really got the same idea. And the Gopher, actually, because both share the same avatars. Uh, okay, so what's the biggest point of Go? The standard library. The standard library actually has no actual rule on what should be in and out, they basically said, okay, we are trying to get to the Google's use case, which is networking and web services. So the standard library basically has IO, networking, and crypto. So everything related to these three things get included in the standard library. But other than that, there is no rule really. So you can have like strings helpers or slice helpers. And other really strong point of the standard library is the interfaces. So you have the packages like IO, FS, and NAT, HTTP, which has which all of them have like really important interfaces on the Go ecosystem, which is the reader, writer. This basically lets you abstract every single possible uh, file system, everything, networking that can be read or written. FS basically abstracts the file system. So, for instance, in Go 1.16, I guess, they introduced the embed flag, which would allow you to put blobs on the binary. So it is actually an abstraction of a file system. So you use the same interfaces you would use, like imagine a web server. You are reading files from the HD, from the hard drive. You can actually use the same code to read from your binary right now. So you just removed the file system from the architecture of your services. And the HTTP handler, which is really awesome. I'm going to give an example of usage of it. And here you can see an example of something you can do. So you have this multi-writer, which basically receives a lot of writers, like things that implement the interface writer, and set them as the output. So in this case, your logs would output at std out, some file, or some UDP server, like a socket or something like this. So it's really that simple to use those interfaces. Oh, by the way, Rob Pike actually said that he regrets doing std out as a concrete type like this. He thought it would be better to actually implement the interface and not like a concrete type like this. So it's a bit of Go history there. So HTTP handler. This is a really simple interface. So basically, you have to implement a method called serve HTTP, which has two arguments: receive response writer and request. So why does it matter? So let's see an example here. This bit of code has a lot of error handling. So you can see that the get value, see like do error handling here. The execute template does another one. And you can imagine, like, if you do multiple queries on the database or something like this, you're going to do a lot of if error and like put the HTTP error after each one. You can forget about it, and this is really awful to work with. Oh, by the way, Go doesn't have uh, a return, I don't know, type on the uh, request handler for a single reason. All of the HTTP stack is done upon like interfaces. So actually, all of the actions you can do on a web server in Go can actually be written like plain functions, and you can like reorder the functions the way you want. So you don't return because you can actually just change the order of middlewares, requests, or handlers. So by not returning, this gets way easier, because otherwise you would have like to change the returns of every function or the types. And this is a way to circumvent this. So imagine you would want to implement error handling on the web server level, so not on your application code, you can actually just write a type alias like this, which is basically saying, oh, everything that satisfies this rule here, like a function that receives a response writer, request, and then returns a error, will have the serve HTTP too. So basically, these right here say, I'm going to receive function fn, which is a app handler, and pass the response writer and request. So you can actually see this in action here. Now the code becomes this. So we just do a if error here. We don't care about the error because our function here is taking care of this. The template just returns an error, so we don't need to check it too. And we just pass our function view record to the app handler. So it will be this guy right here, and everything works. And why does it matter? Like, okay, what's special there? This shows that Go has a lot of common patterns. So all web handlers are going to have this signature here, which is the response writer request. You can actually change the library, so you can change your router, you can change your middleware, you can change your server, whatever. It's basically always going to work on the community libraries because they work upon the standard library, because it takes care of the most common use cases. And another point is that this will always work on Go 1 point whatever. So they have a backward compatibility rule that Go should never break its syntax. Like, you can get code from 2009 and compile with a new compiler. So basically, when you update Go services, when you update old Go services, you're basically just getting the improvements on the compiler because it never has breaking changes. Okay, so this is not perfect, right? So where did they fail? So they failed on logging. We don't have a common logging interface on the standard library, so you get a really fractioned community effort. So you have lots of libraries, lots of ways of doing things. It's really awful because if you work on a big company, you start to see projects using like I don't know, HLog as a library, another you use Zap, and it becomes a mess. It's awful. And iterators. So Go doesn't have iterators. It's really awful too. So they are actually being discussed right now, a way to actually implement iterators and logging in a common manner, so you can get the middle ground. But other than this, the standard library really made a huge impact on the community. The community actually waits for things to get on the standard library, like the file system interface that wasn't there. Uh, it- we actually have a discussion right now to add a remove method on the file system interface. So because right now you can just open files on the file system through the interface. You cannot like remove or modify the file, which sucks. But they are actually discussing on putting this on the standard library. Uh, Another thing that is actually really nice. My slide got a bit wrong here, but it's the tooling. So the Go team actually works really hard upon tooling, as the standard library should just integrate with your system and basic usage, like really nice. They also think that the tooling should follow the same path. So the beauty configuration is really simple. You have Go format, which basically makes all Go code look the same, and it won't even compile if you write it wrong. I thought this was really weird at first, but after this, I really enjoyed. So I on the companies I worked, I've never seen like a discussion on style, on indentation, or I have never seen bad code pass on CI. So it's really nice. And the language server protocol, well, it's the most well-known thing ever. So, but basically from the day one that the protocol got the specification, they started working, and it's basically the best language server protocol I have ever used. They go really after the performance side of thing, so it's really nice. About the building configuration, it's really really simple. You have, well, yeah, the most important environment variables, because it works on environment variables. You don't have config files, you don't have any other fancy stuff. It's basically just environment variables. You have go path, which is mostly deprecated. I'm going to get deeper on this matter after this slide. You have Go OS, Go Arch, and CGO enabled. So Go OS and Go Arch basically defines the operating system you're building to. So you can be on a Mac machine building to Linux. You can be on Linux building to BSD, to Plan 9, to, I don't know, DOS you want. Go Arch basically will build to the architecture. So you can really be on Windows building for Mac with the M1 processor out of the box. You don't need to install anything other than the Go compiler. This is by design due to the C compiler they had before. So as they already had their own assembler, their own compiler, why not just make it multi-platform? So you can actually, I don't know, build to Android from Windows, from BSD. And the coolest one, which is basically what defined Go on the cloud, on virtualization with Docker, not virtualization, but with containers, is the CGO enabled. So with one flag, you basically say, do I need, do I want dynamic linking? Yes or no? So you just put one or zero, and you have a static linked application. On Docker, you don't even need a runtime like Alpine or Debian. You can use Scratch and have only your binary running because it's statically typed, linked. Sorry, statically linked. So it's really nice. It's really easy to handle. Uh, what about the Go path? So right now the Go path has a reduced scope. So it basically says where the dependencies you download are going to be, or where Go binaries you install are going to be. Before 2018, I guess, or 17, I don't recall, Go path actually defined where you would work with Go. So at Google, they had the huge repository with all the Google code. So you would just point to Go path to this directory. It would look after Go source code, and it would work this way. So it was really awful to work if you weren't to Google, because you would have a directory on your computer that you needed to work on. So you couldn't like go to slash projects or something like this. No, it's on the Go path. Otherwise, you're not going to see your dependencies, your other projects, and all of this. The reasoning behind the Go path is that they wanted you to take care of the dependencies, so not just vendorize everything and just forget about it and never care about updates or something like this. I don't really get this, because you can have other package managers which are really nice, but right now they introduce Go modules which basically make GoPath a little bit smaller, so you don't need to code on GoPath anymore. And with Go modules, you now have decentralized dependencies. So as you can see on the example below, I'm importing quote from a random URL on the internet. You can actually host your own with just a HTTP server. It's really awesome. I really enjoy this. But there's a problem. What if I have a big company with thousands and thousands of engineers and I really like the dependency that, I don't know, a random Kazakh guy just made? I'm going to basically DDoS the guy. So they built the Go proxy, which is by default is a server that is running on Google. So if I get this, I'm going to get through a Google server and it's going to cache it for me so I don't DDoS the guy. You can actually host your own if you're imagine you have a company that do some security work or some private work. You can host your own Go proxy so you don't need to go over the web. And it's basically this the presentation. So my conclusion is that Go did a lot of work on the community side of things with its tooling, especially with the tooling. So you can have like just binaries on your path, and everything is going to work just fine on every computer ever. Uh, you have interfaces that basically define the whole community, and they are open to discussions on introducing new interfaces on the standard library. So you can actually just swap things and test things, whatever what you want. And I think this is really valuable, uh, even more when you're just testing out products or you want to test out new methods of doing things, because you can just leverage the interface on the standard library. Oh, you didn't like your code, you didn't like what you built. Okay, let's just use a community library and everything's fine. And yes, it's basically this. I hope you guys enjoyed. If
I
you
have a
have any
question.
questions. Okay.
Yeah, so about the standardized nature of the thing, I got the benefit out of it, which is that basically when you know how to read Go once, you know how to read it everywhere because it's kind of basically the same all over the place. But you mentioned something that got me worried, that you said that people are waiting to something to become standard. And as far as I can tell, this has the potential of like decreasing novelty because everybody instead of doing, they will wait. And I think that can be bad, right? You are losing one of the most powerful benefits of an open source project, which is that people are working for you. But if they are rating to something to be standard, they are not doing stuff, they are rating. Would you classify that as bad also?
Not really, because you have this on logging. So logging, as I said, like logging and iterators in Go, you have a lot of work on the community already. You have like for all the flavors you want. So you have like really performant loggings, really easy to read loggings. So the problem is there is no middle ground on it. So you can't actually work on multiple projects with different logins. But you can, however, work on multiple projects with different routers, or routers as in the HTTP router, or multiple, what's the name of it? It's not muxes. I forgot, but you can do this interchangeable work with other parts of Go, but not logins. And all of the, if you look at the, I can put the link here. If you look at the discussion, you actually see people from other communities working on making this standard. So on the logging discussion, you actually have a lot of .NET folks discussing how they did with .NET and what would they change. It's a really hard job. So because if it gets to the standard library, as you said, this is going to be forever there. And as I said, Hobpike, also regrets a lot of things he put there. So it's a double-edged sword, you know. So
Okay, so the community is actually also helping to make things standard as Go goes forward. Okay,
yes.
okay.
So another thing that happens a lot, I guess, is that there are a lot of discussions that won't go far away. For instance, the generics. We had lots and lots of issues, discussions on how to implement generics. It's really hard to contain the community because it gets heated really hard, really easy. Sorry. There are people that do a job that requires like more sophisticated type system. There are people that do not. So you have this type of thing, and when it gets to this point, I guess the Go committee just basically stops the community and starts over until they get a good discussion, you know, a healthy discussion. But it's basically this.
I have one question. Um,
Yes.
One thing that bothers me in conventional software development, and I think you will relate, is that nowadays you have this longing people have to. I think it's just a stimulus that people have to create this interface hell. I think you can clearly see that on like .NET Java, right? You start to make like interfaces to generalize stuff, but nobody knows to try to force stuff in the standard. But stuff don't end up in the standard. You just end up with a crazy interface to access your stuff, right?
Yes.
Um, so I appreciate like very much the effort and this stimulus that uh, the that goal tries to like embed in the community, right? And I, but I also think like to simplify usage. I think that's the term, right? Uh, but I think that also, and in the beginning you said on that quote, you're saying you like the philosophy, whatever it may be, uh, but not the language. But then that got me thinking. Okay, so the same philosophy and the stimulus that created .NET and Java to become the way they are, don't you think that the bad features they're also a direct consequence of this philosophy? So that's my question. I don't know if it was too complicated, but anyway.
Okay, so there are two things that I think that Go gets right to avoid the interface hell or the abstraction hell. As you can see here, one of them, as you can see here. So, as I said, this interface, like the handler interface, just expects a serve HTTP method. That's it. If you look at the implementation here, you have no mention of the HTTP handler. Like you cannot see that this implements an interface. So there is no
Yeah, it's not like
incentive. Yes,
yeah.
there is no incentive to actually be implementing interfaces every time
Mm-hmm.
because you actually don't need an interface to actually build code. So, for instance, on the server HTTP, you you're going to put the code here. You're going to say, "Oh, this is expecting an interface." But is my structure being made just to satisfy this interface? No, not really. You can put your own methods, and if it has a server HTTP, it's going to work here. So there's no incentive to abstract things behind interfaces,
Mm-hmm.
you know. And the second point is that Go has a basically a document saying the philosophy of Go, as I put there, that says that interfaces should be small. Basically, this make it as small as you want or as you can, because otherwise you're just going to do a general interface for the whole program, and it's going to get out of hand, you know. So it's not something that is on the language. It's not something that is actually said really much. It's just convention
Mm-hmm.
over the community.
I think the only that's good. Thank you for the answer. But I think there is only one problem I see with this is that people start have the feeling that this is very easy to be taken ideologically. Like you start to forget about the reasons why you want that, but just because you want to conform with something that I don't know the community stipulated as good. So you're not thinking of and not thinking of like special cases and anything else. So that's my only concern.
Yeah, I think I got your point, Mageta. As far as I can tell, there's nothing in the language itself that like forbids the bad usage of it.
Yeah.
The good use of it depends on the people using it,
Hmm.
which is a very trustworthy system. You need to
Yes.
trust the
Yes.
community. Because if
Yes.
you
Yes.
don't trust, the tool that you made is actually not forbidden, making it like obligating them to follow the rule. They can do bad stuff, which is risky. It's a risky move, but I think it comes as a consequence of the simplicity, the philosophy of simplicity, or the philosophy of being able to standardize everything. I think it comes this trustworthy philosophy.
Hmm.
But you're totally right. I had the same feeling about this. It's like it depends. It depends on the community, which can be bad because some communities there are very toxic. And
Yes. I guess the Go community kind of get there.
uh, but anyway, sorry to
Dictatorship.
interrupt you,
I like
Victor,
it.
but I totally agree with Maketa on this.
Yes, there is really nothing like saying, "Oh, you shouldn't do this. I won't compile because this interface is trash." There is really not something that do this. What basically makes the community follow the whole small interfaces uh, is the standard library, really, because basically what you're going to do with file networking and all of this is use these two interfaces, which is reader, writer, or the bigger one, which is reader and writer. So it's IO, reader, writer. And yeah, it's basically the standard library that is making the effort to reduce Go code.
Mhm.
So they try to keep it really small.
Yeah, but if you think about it, like in the beginning, as far as I understood, Go made this for themselves, and they like it's kind of natural to you to trust your own employees, so they don't have to make the language obligate stuff because they are making something to themselves.
Mhm.
But later, when they made the thing open, now this can be a problem because we don't trust anybody else aside from ourselves, right?
Mhm.
So yeah.
Yes, basically this. So
You
it,
can still do that if you manage it like dictatorship,
Oh
right?
yeah.
well, they do have it.
Yeah, so
Uh,
that's a good thing.
there's a thing on the standard library that is a bit of archaeology that someone can do. That is, the standard library was not as big as it is today. It's not really that big today, but it was basically a Go version of the Plan 9 standard library. So basically, all the methods that we saw on the Go standard library was on the C standard library for Plan 9, because mostly because of the 90p protocol. So you can actually see the reader writer interface that you could use with 90p protocol, which is used by Hyper-V and WSL to communicate through processes. So,
Another question.
okay.
So you don't have your answer does not have to be like biased because Mageta is here, myself, Renatan.
No, don't
But
worry.
if you had the power to add a feature that would not break any other Go code going backwards, because as far as I can tell, this is a mandatory stuff. You cannot
Yes.
break stuff. What?
Good. It's
Which
not like
feature?
Python.
Which
Change a
feature
minor
would you
version
add?
and it works. Yeah.
If you had the power of, I'm gonna add the feature. Everything will work backwards, but the feature will be there. And
Mm,
you cannot say something that is already there, like generics, for instance. So you need to say something else.
dude, I would say union types.
Oh,
Oh.
on the
Yes,
errors, I think that would be good.
really union types. It's the thing that I guess most people miss in Go because it really sucks to do if analysis or switch cases there every time. So I guess it would be union types,
Well, union
like for
types
sure.
mean something to allow better handling then.
Yeah, allow better error handling. Do a proper enum, because Go doesn't like Go has enums, but it's not really a enum. It's the iota stuff. So it's basically a variable that you put equals iota, and every variable you put below becomes like iota plus one. So I guess it would make it easier.
Okay, so you would add a little bit of like a little bit of strong typing, just a tiny
Yes,
bit.
yes,
Okay.
absolutely. Uh, I didn't want to get into the language here, but the iota problem is really a problem because imagine this: you have variables, like imagine this C. Uh, you put iota on it, and it has zero. So you define another variable below. It's going to be one, blah blah blah. But the problem is, as in C, if you do if zero, it's false. If one is true. So if you did if C, it would be false, and if D, it would be true. So it has this problem. Not sure if this it was clear, but
Oh, you mean that the D would have iota plus 1, so it would be 1 because C is 0,
yes,
but reading the code, you wouldn't know.
yeah. So this is
Oh,
why
that
I would like
sucks.
union types, because otherwise you could like say, oh, if this is C, do this. If this is D, do this. But C would always be false, so it would never be C. So
Yeah,
this
yeah.
Talking
sucks
about
so much.
how Go doesn't have some types
Yeah, no,
because
it's
I
because
got
I
a
Yeah.
asked
solution
him
for
which
that.
feature, if he had the power to add any feature he wants without breaking backwards code, which feature he would add, and he said some types.
There's a trick. This is a bit of a hack, to be honest. What we do when we want some types, we use protobuf definitions. So instead of defining the types directly in Go code, just define it in protobuf. And protobuf does have some types, so you can do that. Plus, your types are portable, but your code looks kind of bad. Though. So there's that. But
Yes,
yes, it
there
works. Yes.
there are a lot of code generation tooling to do with most of the things Go struggle, right? I
Yeah,
guess some
definitely.
types. Another one is generics because generics in Go is not like you guys imagine. So it's really just a constraint definition. So imagine like a comparable constraint would be like string ints and numbers in general, and you would put here, oh, this would receive a comparable. It's not like you put
Like
t and it just
special
works.
interfaces, right? Like
Sorry.
it's like reducing to the interface or something, right?
Not really. It's basically it works on types actually, but the problem is that they only work on default types. Types that comes with the language, like string ints and floats. So you can have like, oh, this instead of response writer is going to receive just numbers. You have
Mhm.
a constraint just for numbers, but they are not actually like we imagine. Imagine that the compiler basically is going to generate code for all the numbers
Yeah.
That's
types.
a very lazy way of doing that.
Yes, but yeah, the reasoning behind this is not to not break Go code. So it should be something that you would be able to compile old code. And there's another one which is the build time. So imagine doing like a really nice generics with Go and then just bankrupt Uber on the CI.
Nata is asking, can you implement those things for user-defined types? poor man's type classes.
Totally
Mm,
Pursman type class is what he said.
no, you cannot. No, absolutely not. You
Uh,
can just work on constraints on the standard
Well,
types.
this sounds bad to you
of
guys. I'm sure this
course.
sounds bad,
Of course.
but I work with Go daily. I work with it, and I can think of only one situation over the past few like 6 months where I missed generics. I haven't missed them since.
Yes.
So
There's a question
sounds
though.
bad, but
But there's a
you need
question.
it less
Are
than you
you
think.
inside the mindset? Like, are you already predisposed of
Yeah.
like just standard types, and then you forgot how easy it was with user-defined types, or the situation was really just standard types? You don't need to define your own.
Wait, I don't get the question, but I think I got the spirit of it. And I am telling this coming from Haskell, so I know what the good type system looks like. The thing is that Go is not that language, right? So you can reason about the memory that your structs are going to take very efficiently because you have like a level of control. If you want to use generics, you kind of lose that, right? So it's always a trade-off. It sounds bad, but I don't think it's as bad as. I mean, interfaces replace generics in most of the cases I need it anyway.
Yes, there's a thing too because as the whole language is built upon the idea of not having generics, you really don't miss it really much because
Yeah,
imagine this like the I guess the simplest example would be like a sorting function. Dude, you don't have much types, you know? You don't really have much types in Go. So there's nothing
I mean
wrong
there is.
on
Yeah, there is a sort library, and you just pass a function that does it.
yes. So I guess
It's fine. It's
the worst part of uh, the sort, I guess it's sort, right? The worst part is that you have to actually write the arguments and the types of the arguments, but other than this,
uh,
it just works fine. And there's another thing that I actually miss doing C sharp and F sharp. I guess .NET is the new. So new is actually not a I don't know, generic type, you know? So I cannot just put like instead of int, it's new, instead of an object or struct, it's new. I cannot assign
What are you
new
talking
as
about?
this.
It's awesome.
So I really miss this on .NET. So I really wanted that new.
That's actually the feature I didn't want in .NET.
Yeah,
Why?
there's an entire debate about how Magetta hates news, and he's fair. Like it's a
It's a
fair
it's
argument.
a hole between a hole in your
nope.
school and a NUI. I prefer the hole.
Yeah.
Like NULL.
You take that.
Like we were discussing about making our silver arrow stuff, and then Magetta said the first thing, the agreement to him to participate is to not put new in the language.
Oh. Oh
I think
yes.
that's fair. That's a point of contention. I think it was. I'm not sure what is the rationale behind allowing null values in Go, but that's one thing that I don't quite like.
As always
Yes.
remember, null values is a contradiction in terms. Let's think of that.
Yeah, you can do a presentation about that topic, by the way. Would that be
Yeah, just about null.
just about new a rant? The title would be a rant about new.
I will do it. I'll do it. I'll picture a date.
Okay, feel free. So anyway, so Breno, do you have any other questions for Victor? Because I already made two questions. Magetta did one question.
Yeah, I wanted to ask actually about the Plan 9 heritage because that's something I'm pretty interested in. It feels
Yes.
like Plan 9 is something that is super like unknown. Don't Not many people know about it, but it's something that's going to pay dividends for like the next many years. So the main one that you said is that it's highly based on the Plan 9 C compiler. And
Yes.
was a really cool. I found out about it. I think they had many, because the Plan 9 operating system was meant to be run from like many computers. It's naturally from distributed systems. So they had like, if you wanted to compile for x86, they had 8C. So like I typed there, the compiler 8C. I think that there were like for every architecture kind of there was its own compiler. So that's pretty cool. Um, I guess I don't have a question. I just want to comment if you know more about it, because this is something that I find pretty interesting.
Yeah, so something that I would say is the biggest influence on ever in Go is that Plan 9 is really simple. Like I mean it. It has like a graphical interface. It has a network stack. It has everything. And if I recall correctly, it goes a little bit above 100k lines of code of C code, including the compiler. So this dude, this basically made Go be the way it is. So they used the C compiler, which has this ability of actually compiling to multiple architectures, and they use it until Go 1.11, I guess. So they were using this compiler for a long, long time, and they worked on the Plan 9 compiler for a long, long time. So indirectly people were using Plan 9 code. Uh, Other thing that has a really big influence on the community is that I am not sure if you guys know about the projects as Perkeep and Spinup, I guess. Upspin, sorry. Perkeep and Upspin. Upspin is actually a Rawpike project. It is based on the ideas of Plan 9. So, as you said, it is a distributed operating system. And Upspin actually embraces this idea. It's basically an application that is going to store things forever for you. So you can connect it. Yeah, the idea was you can have a federated network like Google Drive, but on your server, and give access to people like uh, I don't know, Mageta at uh, I don't know, divisions.com or something like this, and he would have access to some files. And it was written in Go by Rob Pike with the same ideas as Plan 9, so a distributed file system, a distributed file sharing with federation over email. And it's really nice. Perkeep is actually, I guess, it's a fork, but it went further. So it integrated with other systems like Twitter, I don't know, Discord. So you can just export your data and save it forever on Perkeep. So it's really awesome. I guess
I had
the
never heard about that. That's really cool.
yes, I mean you can go to both websites and try to read more, but I don't think you're going to understand it over the website because they are really bad at selling. So
Yeah, 100%. What is the other one? Can you send a link?
yes,
I'm
I
interested
can
in that
send
actually.
the link later.
I'm
Or
Yeah,
talking
one thing
about
that I
cool
actually want
things.
to
Go, Ben. Go.
one last thing, like speaking of Plan 9, the 9P protocol is actually found in surprising places. If you use
yes,
WSL2, you're using 9P because that's the protocol they use to synchronize the file system over the network. If you use Nix, I think Nix also uses 9P to like manage the packages, like the package database. So that's interesting. Like it's supposedly a really simple protocol, so people just go implement it instead of like something more complex.
it's really lightweight. So and you can it's really flexible too. So Plan 9 actually used this to share a lot of things. I guess the most famous talk or demo of Plan 9 is actually a guy accessing like I guess a X server through 9p, doing a tar, sending through the network, untarring the thing, connect to the 9p over other computer, and it just works. You can see the windows on another computer over the network doing tar. So and this is all possible because of 9p. So 9p basically
And
speaks
this is from the
everything.
90s. This is like 30 years ago. And we're still
Yes.
catching up. That's pretty fascinating.
And we still cannot like watch a movie together with other people. Okay, so I guess Lemos had a question.
Yeah, my question is about because Breno said that, oh, this is cool. Something cool that I remember from the presentation is the fact that you said that you can target which architecture or which operating system you're going to compile the code to. So my question is, when you're writing Go and you are calling like a function that depends on operating system, so for instance, I don't know, an environment variable, would that be also compiled to the correspondent environment variable in the the target operating system?
Yes, in this
That's
specific case,
cool.
yes. Uh,
Yeah, because usually you need to do a bunch of ifs and elses to check which operating system you are, and then to check the correct environment variable, like map. I want this, but in Windows is this other name. Ah,
yes. Uh, yeah, like the name of the variable should be the same, but uh, there's a there's two things on this. The standard library actually does not really give much. The people that write the standard library the won't give much attention to systems that are not Unix like. So you can actually go there and open a pull request. Like people did this to uh, introduce, I guess, SIMD optimizations when it's available. There are other people that did this work with the environment variable, but there are parts of the standard library that actually do not take are not really good. For instance, the file handling, like on Windows, it sucks big time because it basically just expects Unix permissions, Unix groups, Unix users. So you can really just put like uh, 777 as a permission of a file, and it kind of get translated to Windows, but Windows doesn't know what is 777, so the code base starts to feel weird, because it's not really expressing what's going to happen both on Windows or in Linux or Mac OS.
okay, I see. So it has a
So
bias towards Linux, Unix-based stuff, which is
yes,
fair
but
because doing like what I said of changing names and changing permission, like architectures, let's say, like permission way of doing things, that would be pretty like, man, like what are these guys doing? Because this must have to take a lot of time. But yeah, okay. Thanks for the answer there. So
uh, I guess yes, there's a really good article uh, of I don't recall the name of the guy, but it's really famous talking about this. That Go basically just says, well, screw up Windows or other operating systems. I'm going to focus on Unix. Like Rust is actually way ahead of Go on this matter. But
what did you
yes,
say, Magetta?
I said based behavior.
Well, Microsoft also gave up already because now WSL is basically a signature that they give up. Uh, so there's that. So okay, people. So any more questions for Victor? Uh, Nathan, Breno, Magetta. I don't have any more questions. That's why I'm asking.
No.
all right. So I'm going to send the links over
Yeah,
the Discord chat.
yeah. So please do
I
that.
think Nathan has a question, right?
Okay.
Yes, you can. I did compile to WebAssembly.
Okay. So it has a place on Nathan's heart. That's good.
Yes, you can compile to WebAssembly. Actually, there are people working on a Go compiler on the web browser, so you can actually work with Go on the web browser just as you would do on your computer. Yes, you won't have like file system or things like this, but you can write Go and have like IntelliSense and everything over the web browser.
Yeah. So definitely a place in Nathan's heart. Definitely. Uh, okay. So I will finish the recording now. Okay, Victor.
All right.